Hey everybody, so I'm going to walk you through the spectrophotometry experiment so that when you get into lab you are ready to go. You're going to have either blue or red dye and Gatorade on your tray when you get into lab. I am demonstrating with just the blue today, but if you have the red, the procedure is the same. The initial stock concentration is different between the two, but other than that, everything else is the same. Quick reminder, you need the calculations from the pre-lab to do this experiment, so make sure you do those in advance. You need those numbers so that you can plug them in to the instrument when you measure your concentration, your standardization curve. Okay, so first what we're going to do, you're going to have two different bottles. You're going to have one that's kind of like a larger version of this that's going to have red or blue stock in it. That's what you're going to use in the beginning to make all of your dilutions and set up your SpectroViz instrument. After that, after you have measured all 10 of your dilutions, which you're going to make in test tubes, that looks like just 5, but there's actually 2 rows there. You're going to make all your dilutions in test tubes using volumetric glassware. Then after you've measured the all of the absorbance values for these various concentrations of stock, then you're ready at the very end to dilute some sports drink and measure that absorbance as well. So you'll have 11 absorbance values altogether. Only 10 of them go in your curve. The other one is your unknown, which is the sports drink. Okay, so let's get down to it. I chose pipettes because I didn't want to carry a burette all the way home. But of course, you can also use a burette. If you're going to use a pipette, I would recommend one that has graduations on it, like this. See, it has markings for various different values, which will allow me to fill it up to the 0 mark, and then I can just pipette 1, and then from 1 to 3 will be 2, and then, you know, continue on like that to get as much efficiency as possible. Okay, so I'm going to try to show you this. Oops, that did no good. Hold on. Okay, that might be as good as we can get. So we're going to start off for our dilutions by, the first one is just going to be water. And you don't even need to measure that one, so I'm not going to put that into my pipettes. You want to use deionized water, so this is my DI bottle from the lab, because we're trying to eliminate any possible contaminants that might influence our readings, right? And so then you're also going to need your stock solution, which will be on your tray. So just a quick reminder here about how to use the pipettes. First you squeeze A, and then squeeze all the air out of the aspirator bulb so it's flat. And then I have poured some of my stock solution into a clean beaker. Do not pipette out of the stock bottles. It's a big no-no. It will make a mess for everybody behind you. And then I'm going to put my pipette into my solution so that the pipette is hovering. So this is all the way down. Hopefully you can see that. So I'm gonna just push the S button. That will suck up some of the liquid. Oops. Oh, mine's wet. Really, you need to try not to get any liquid in the top of the bulb because they work a lot better if the bulb is dry. Alright, and so this is a lot easier to do if it's completely dry. I overfill it just a little bit. So here's my 0 mark, and I went a bit above that. And then I'll drain it, and I want to make sure to be looking at it eye level so the meniscus is right at the 0. Oh, I got an air bubble. I'm going to just get rid of that. Oops, that was the opposite. I pushed S. You need to push E to get rid of air bubbles. Make sure the whole column is filled with liquid. I'm going to just fill it back up again. Again, going a little bit over, and then draining it down. Okay. So the first dilution calls for 10 milliliters of stock. That's not a real dilution, so I'm not going to put that in my test tubes. Then the next one is 9 milliliters of stock. I seem to be having a problem with my seal here. It's stuck on air. There we go. So I'm going to pipette from smallest to largest just by preference. So I'm going to put in 1 milliliter. So I'm going from 0 to 1. And then 2 milliliters. So that's going to go from 1 to 3. It doesn't stop the instant you want it to, so you got to be very careful to stop a little bit earlier than you think. So that was 2 milliliters, and I'm going to go from 3 to 6 to give me 3 milliliters. Oh goodness, I pushed the wrong button. Okay. And of course, 4 milliliters will be from 6 to 10. With these pipettes, you want to make sure not to drain past the 10. They're not calibrated the same way the other kind of pipette is, where you want to drain it all the way. These ones just go to 10, just to where the markings stop. Okay? So you keep doing that to get all your dilutions in there until you've got, you know, 1, 2, 3, 4, 5 mils, 6, 7, 8, 9, 10 mils of stock. And then you're also going to have no mils of stock, right? You're going to have just water as your other measurement. Okay, so you're going to use a clean pipette or a different burette to measure your water. I don't have one at home, but you will use 2 different ones or clean them in between. I'm still not pipetting out of my container. I don't like to contaminate stuff. So this one had 1 milliliter of stock in it. That means I need 9 milliliters of water. All of them end up with the same volume. That's the idea here. All of them will have 10 milliliters at the end. So in this case, I'm going from 0 down to 9. Okay. Then I fill it up and I do the same thing. Only now, I only need 8. Okay, so these are the dilutions I just did. You can see this is the most diluted one, and this is the least diluted one, if you want to think of it that way. So this was 1 milliliter of stock, 2 milliliters of stock, 3, 4. And then, of course, I put enough water to get it up to a final volume of 10 milliliters for each one. And then the other thing to do is you do need to mix these, all right? You want to make sure your solution is nice and homogeneous. So this is just dye and water. There's nothing that can hurt you here, so you can just put your thumb over the end and give it a couple of turns like that. Okay, and so you do that for all of them. And once you get all 10 solutions made, you're going to see this really nice gradient, right? It starts off kind of pale and it gets darker and darker and darker as you go along, so long as you are measuring correctly with your pipette or burette. Okay, so these are our stock solutions. We're going to use these to make a standardization curve. Okay, let me show you how to measure that. So the next part of the experiment is using the spectrophotometer. So I'm going to walk you through our little benchtop spectrophotometers, which are actually really great because they don't cost us tens of thousands of dollars, and so we can buy one for each station in the lab. And they're actually portable, so you can take these into the field. If you're a biologist, you can take these into the field and you can actually do experiments to measure like phosphate concentration and things like that. So it's a pretty cool little instrument. And so it runs off of the computer part is called the LabQuest. And the SpectroViz, there's a couple different models, but they all kind of have this square opening, and they have diagrams to show you where the light is going. Depending which model you get, some of them need a USB attached to them and a power cord, and some of them just need the USB. It depends. But they all do the same thing. They all measure UV and visible light. Okay, and so we're going to measure specifically how much light is absorbed as the light travels through our sample. So your sample is going to go in here. The light source is just a couple of LEDs right in this part, and there's some monochrometers and some instrumentation to make it focused into a single beam, a little diffraction grating, and then the beam of light comes out a little window here and shines across, and then there's a detector over here that will determine, compared to how much light we measure in the beginning and how much light we measure in the end, the difference between those is going to be the absorbed light. Okay, so to get this instrument set up, you need a power cord that goes to the SpectroViz. So I only brought one power cord home, but you will ideally have one plugged in. If yours looks like this exactly, you're going to need a power cord to go into there. And then you'll also have a power cord, a different one, that plugs into the LabQuest itself, just to make sure you don't lose your data when the battery dies. I'm going to use it on battery power today, so cross your fingers for me. And then the other piece you need is you need to connect the small cable right here with the appropriately sized and oriented, I always do them upside down to begin with, cable, and then this and the USB side is going to go directly into the USB port on the LabQuest, like that. Okay, so what you're going to do if you have it plugged in correctly is you're going to see this. It's going to say USB absorbance, just like that. Okay, this is a good sign. It means it's all detected, everything's connected and working. The other part that you need is some cuvettes. So these are just little plastic containers that are specially designed to be exactly 1 centimeter from inside edge to inside edge. That means your path length is 1 centimeter. These, depending which ones you get, some of them have ridges on the sides. Let me show you. When you look in your container and you're trying to choose a cuvette, always look for the one with the least amount of scratches on the sides that are not bumpy. So I think I'm going to actually go with this one. You should use one cuvette throughout the entire experiment. Don't switch back and forth. Your blank and all your samples should be one cuvette. And so basically what you do is you put a little bit in there, and to clean it, you just shake it a bit, dump it out. This can, of course, go in the sink because it's just food dye. Ooh, almost spilled. Did you see that? Good thing that water has such a high surface tension, or it would have spilled. All right, so I like to rinse it about 3 times just to really make sure that any dust or, stuff from the last experiment is taken out. And then you just fill it. Okay? And our last step is always to use a Chem wipe, which you're going to find in the center of your bench, near the pillar and the sink and stuff. They're just little like tissue looking things. And you just wipe the sides clean and make sure there's no dust, make sure there's no fingerprints, nothing like that to get in your way. All right, and so that's how you load a cuvette. The first thing we want to do, once this is all set up, is I'm going to click, when you click on the red screen, a little menu comes up. Okay, and it might be tough to see, but this menu actually says meter setup, calibrate, change wavelength, and spectrometer mode. We're going to click calibrate. And when you click calibrate, the first thing, oh no, I spilled my dye. That's okay. So the first thing you're going to see, there we go, is a menu that says it is taking a dark sample. It's already gone by. That just means nothing is in it. So don't put anything in when you first start up your SpectroVis. And then you're going to let it warm up for a few minutes, okay? You want the light to be nice and stable. Once that's done, it says place a blank cuvette. I don't know if you can read that. There you go. Place a blank cuvette in the device. And then there's two buttons, finish calibration or cancel. So a blank cuvette is just going to be water. And again, since I just had my dye in there, guess what? I'm going to rinse it a couple of times. So we just want to use DI water, the same water that you diluted your samples with. This will take out that background so that it's not going to interfere with your results. Now, if you look closely at this, you can see there are bubbles on the top and little splash marks and everything like that. You want to minimize that stuff. Anything that changes the path of the light. So you want to wipe off the outside every time. Unless you're real careful about how you hold the cuvette. I wasn't. I put my fingers all over it. But if you only hold it by the top, you don't have to wash it every time. The other thing to look for is bubbles. If you have a lot of bubbles inside from pouring it in, you just kind of tap it. Sometimes I get a pipette and poke them. Okay. But when we put this in there, there's two sides. There's one that has kind of a reflective bit to it. You may not be able to see this with the water in there. I'll show you when we get the dye. But there's one that has bumps, and there's one that doesn't. It's just a transparent piece of glass. Plexiglass. It's plastic. You want to put the transparent window so that the arrow on your device is pointing through that transparent window, not through the bumpy side. So we're going to put that in there, and we will click Finish Calibration. And this is telling the instrument, this is the water. This is what 100% transmittance looks like. All the light going right through. Okay? After it's done, it'll say, give you the option to click OK. And it goes back to the regular screen as if you haven't done anything. But you have. You have told the instrument this is what nothing in there looks like. We call that the dark sample. And this is what the blank looks like, just the water, the solvent. Okay? So then, now we're ready to start our experiment. First, you're going to use your stock solution, not diluted at all, just the stock, okay? And again, I'm rinsing because I just had water in here. I want to make sure that I'm only doing the stock solution. Okay, so 2-3 rinses is good. And I'm being careful not to put my fingerprints on the windows that don't have ridges, and I place this back in the cuvette. You don't need to fill this to the tippy top with liquid, by the way. You just need to fill it so that the path length, which is about halfway up the cuvette, the light path is clear. So it's in mode full spectrum, and I'm just going to click the play button. Oh, actually, I forgot. We're measuring too much. I'm going to reduce this. We actually want to measure when we click on the mode button. So what I'm doing is clicking in this upper corner where it says mode, and I'm going to set it to go from 380 up to, sorry, it's 350 to 680 is what we're shooting for on this one. So I'm entering 350 as my minimum, and I enter 680 as my maximum, and then I hit OK. And so this is going to focus in on the visible range of light. And so I click the little play button in the bottom left corner and let it run until I see a nice absorbance curve. Looks something like this. If I can get it to show you. All the reflections are a little weird. This is actually a rainbow. I know it's tough to see. But it's a rainbow, and then it has a little black line going through it. So then once I get that, I click stop. And it will automatically figure out what our lambda max is. That's the maximum absorbance value within that range. And it's important to use that value in Beer's law problems because it is where you get the most consistent readings. If you choose a place that is not the lambda max, a wavelength that is not the maximum absorbance, it's much less reliable data. So in the case of this blue one, what I got just now, and it'll vary from one person to the next, but you look in the bottom corner down here and it'll tell you your value. The one I got was 46.450 nanometers, so I would write that in my notebook. That's your lambda max. That is the maximum absorbance. Then we're going to go click in the upper corner here You can click on the icon that looks like a speedometer. It's next to the file, but it, you know, looks like a little speedometer up here. And it'll take you back to the starting screen. At this point, I want to click where it says full spectrum, and I want to change it to events with entry. The event is going to be that's our concentration. And in our case, I'm going to put the unit there as well. I have to use the letter U instead of a micro, but I want to remember that we're using micrograms per milliliter as our unit. So I'm putting that right in there as the unit. Okay, so once you have that done, I'm just going to go ahead and it's going to come up with this menu, and this confuses a lot of people, so pay attention to this. It's going to come up with this menu that looks like an error. Oh man, hold on. I pushed a button. You shouldn't do that. Something I didn't show you is if you're having a hard time using the touch screen, there's a little stylus built into one side. It just slides right out. So you can use that to type in here as well. I have to enter my units again because I hit back instead of what I wanted to hit. Okay. So what this says is you change the mode and have unsaved data. Do you wish to save or discard the data? You must save it to do the next part, okay? So you see how this says, so you want to click on save, not discard. Otherwise you're going to have to measure that full spectrum again. It's kind of annoying. I'm just going to save it as my name, my initials, and I'm going to save it as Absorbance, ABS is what I put. So I put my initials and then ABS, and that way I know what's what. And when you do that, there we go. When you do that, you can see that the wavelength we measured as our lambda max is what's being measured now. So it says the absorbance at 464.5. And so it's telling me the real live value right there, which is changing because I keep moving my arm. So your shadow can make a difference, see? Okay. So pay attention and try to make sure the light source is as consistent as possible, including the area around the device. Don't do this. Okay. So, now what we're going to do is we're going to start measuring our dilutions. And whenever you do this, standardization curves, and we're going to do more later, so pay attention to this. You always start with your least concentrated one first. And I'm still rinsing. Still going to do this. All right? And so you want to just rinse it a couple of times. Don't go nuts. Don't use all your solution rinsing, but you could use a couple milliliters. Make sure that the prior stuff is out. The reason you go from least concentrated up to most is because when you go that way, you're adding less contaminant. Okay? If you go from most to least, you're going to have extra. Anything that's not rinsed out really thoroughly is going to make the next reading more concentrated than you wanted it to be. So just wipe it really carefully. And this might be a good chance for me to show you the lines I'm talking about in the cuvette. Maybe not. No, you can't tell on my camera, but there are lines on some of these sides, and you don't want to... So that side has lines, and that side doesn't. Okay? So you want to make sure that when you put it in the path length, the arrow is showing you the path length, that you are not putting the ridged side, the lines, in the way, because it'll reflect funny. And then, once I got my... Well, I guess I probably should have done water first. You probably don't have to because we blanked it. It's probably fine. So let's start with the diluted one. We're going to hit play. And then you'll see that this graph comes up. And you're going to be able to see in real time. Oops, hang on. Cancel that. You're going to be able to see in real time what's happening with your standardization curve as you measure it. Okay? When you're ready to take a measurement, you have to click on this little teeny button down here by my finger that says keep. Do not hit that red stop button until you have measured all of your standards. So all 10 samples should be on your curve. When you click keep, it's going to come up with an events with entry box. So that means you need to tell it what the concentration of that standard is. That comes from your prelab. Okay, so make sure you record that in your lab notebook and you have it with you because you have to enter it into the device to make the graph. Okay. So then you'll dump this out. Well, you'll click OK when you enter concentration, and it will show you a data point on your graph. Then you're going to dump this out, rinse with the next solution a couple times, measure that one, and you go up, 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 all the way until you get to the sample that is just 10 milliliters of stock. That's it. You should have a really nice line if you do this well. If you don't have a linear relationship, you need to ask your instructor what might have gone wrong and discuss that in the lab. After you're finished getting all 10 measurements, you'll click Stop. And then you'll want to be sure to email this document and your absorbance curve to yourself and your lab partner. Okay? So you're going to need to trade data. You're going to do one color, they're going to do the other color. You should each end up with 2 graphs, 2 absorbance curves, 2 standardization curves. Okay? The standardization curves need to be moved into Excel to be used well because the data that's inside of LabQuest software is not very precise. It doesn't have the right intervals, and in Excel you can control that just like we taught you in Experiment 3. The other thing is you can't put titles or axis titles in Logger Pro, so it's better to just copy the data out of Logger Pro Lite, which is spelled L-I-T-E, and paste it into Excel or a spreadsheet program to make your graph. Okay? So you do have to download Logger Lite, but it's free. Just Google Logger, L-O-G-G-E-R, Lite, L-I-T-E, and you'll be able to find the software for that. It's also linked in your lab procedure. You download it right to your computer. It's free, and that's what allows you to open these files. They're going to be QMBL files. You need to send the data files when you're in lab, so it's going to be a QMBL file when you get to your email. You have to have Logger Pro to open that. It won't look like anything if you try to use other programs.